Hello, in this video we're going to take a look at sketching the graph and finding different components of the graph of quadratic functions. Alright, so for each of these functions below we are going to ask the question, does the function open up or down? We're going to find the coordinates of the vertex, the equation of the axis of symmetry, the x-intercepts if they exist, and the y-intercept. And then we're going to put all of that together to sketch the graph of the function. All right, our first example, we have f of x equals negative x squared plus 6x. Well, in order to answer our first question, does the function open up or down, the only thing we need to look at is the coefficient on our x squared. And our coefficient on our x squared is a negative 1. Since that is a negative number, that means that this function will open down. If the coefficient on the x squared is a positive, it opens up. If it's a negative, it's going to open down. All right, to find the coordinates of the vertex, there's actually two different methods to do this. I'm going to approach one method in this video, but there is another way to do it. And I do have other videos on that, so you might want to check out my completing the square videos for quadratic functions. All right, so to find the coordinates of the vertex, if it is in general form, that's the ax squared plus bx plus c, that expanded form, then we find our vertex is going to be at the coordinates negative b over 2a and then f of negative b over 2a. Because remember, with any function, if we want to find a y value that corresponds to an x value, we can just plug that into our original function. And so our vertex is going to be at negative b over 2a is going to give us our x coordinate. So our function here, we've got our a is a negative 1 and our b is 6. So our vertex is going to be at x equals negative b, so negative 6 over 2 times a, so 2 times negative 1, and negative 6 divided by 2 times negative 1. Well, those negatives are going to divide out and give us a positive, and then we're left with just 6 over 2, or 3. So that's going to be our x coordinate. Now we're going to take that x and plug it in to find the corresponding y value. And so we get negative 3 squared plus 6 times 3. Negative 3 squared is going to be a negative 9. Plus 6 times 3 is 18. That's going to give us a coordinate of 3, 9 as our vertex. All right, the next thing we're finding is our axis of symmetry. So the axis of symmetry is the vertical line that goes through the vertex. Well, remember, all vertical lines are in the form of x equals a constant. And if it goes through the vertex, it's going to go through the point 39. So our axis of symmetry is going to be the equation x equals 3. Now, if you're one of my students, I am a stickler about having that equation there, meaning you have to have the equal sign and the x equals. The axis of symmetry is not 3. The axis of symmetry is x equals 3. So make sure that if you're one of my students that you include that. And if you're not one of my students, you might check with your math teacher and ask them. All right, once we find our axis of symmetry, we can find our x-intercepts. Remember, x-intercepts are going to be the points on the graph that go across the x-axis. And every point on the x-axis has a y value of 0. So we're going to find our x-intercepts by plugging in y equals 0, or putting in 0 for our f of x, and solving for x. So we get 0 equals negative x squared plus 6x. We do have a GCF that we can factor out there. I'm going to go ahead and factor a negative out with my GCF of x. I always like factoring with a leading coefficient that's positive, so I'm going to go ahead and get rid of that negative on this first step. If we factor out a negative x, we're going to be left with x minus 6. And then setting each of those factors to 0, we're going to get, well, negative x is going to be equal to 0 when x is equal to 0, and x minus 6 is going to equal 0 when x is equal to 6. That gives us x-intercepts, at the point where x is 0 and where x is 6. Now remember, we found those points by plugging in y equal to 0. So the coordinates of those points are going to be 0, 0, and 6, 0. All right, our last item that we need to find is our y-intercept. And we find our y-intercept by plugging in x equals 0. Similar approach as to finding the x-intercepts. It's just now we're looking for the values where our y-axis or our x value is equal to 0. So we're going to plug in 0 for x, and that does simplify to 0. And so we get that our y-intercept is the origin. Notice that if you ever, in any of these problems, get an x-intercept at the origin, you will always have a y-intercept at the origin, and vice versa. You either have both of them or neither one. All right, putting everything together on our graph, we do have a vertex at the point 3, 9. I'm going to go up by 2, 4, 6, 8, 10 on the y, and then by 1s on the x, just so I can fit it on our graph. And so our point 3, 9, x equal 3, y equal 9 is our vertex. We do have that vertical line of symmetry at the line x equal 3. We have an x-intercept at the origin and an x-intercept at 6 and a y-intercept at the origin. Now, if we had got, if we needed another point, if for some reason we only had one x-intercept, because that x-intercept was our vertex, then we could use that line of symmetry to help us get another point. But this gives us enough information to sketch the graph of our parabola. And we do see that our points do line up for it to open down. All right, our next example, doing the same thing, we have our function f of x equals 2x squared minus x plus 6. Again, to find whether it opens up or down, we're only interested in what is the sign on our leading coefficient. In this case, that's a positive 2, so that means this parabola is going to open up. To find our vertex, we're going to do negative b over 2a, gives us our x coordinate. Here our b value is the coefficient on x, which is at negative 1. So we get a negative 1 over 2 times 2. That's going to give us a positive 1 over 4. All right, now to find our y value, we're going to find f of 1/4. And that simplifies to 47 over 8, which is approximately 5.9. So just shy of 6 there. And then our axis of symmetry, remember, is always equal to the vertical line that goes through that vertex. So it's x equals that x coordinate at our vertex. These two numbers here will always be the same. And then our x-intercept on this, if we set this equal to 0, minus x plus 6. Let's see, we're looking for factors of 12 that add to negative 1. And there are not factors of 12 that add to negative 1, because we have to have the same sign, because this is a positive 6 on the end. And the factors of 12 that we have that would have the same sign are not going to add to a -1. So we can use our quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that gets 1 plus or minus the square root. Underneath the square root there, we're going to get 1 minus 48. That's a -47 over 4. Notice that we do see our 1/4 coming out that we see in our vertex. That is not a coincidence. That's actually how this is approached. But we do have an imaginary number. Anytime we get imaginary values for our x-intercepts, and it's imaginary because we end up with a negative underneath our square root, that tells us there are no x-intercepts. And if we go back and look at our first two answers for this problem, that does make sense. We said our parabola was going to open up and that our vertex was going to be at the point 1/4 47/8. Well, 47/8 is a positive y value, and we're going to open up from a positive y value. That means we will never be crossing the x-intercept. All right, but we will always have a y-intercept. So if we plug in 0, we get 2 times 0 squared minus 0 plus 6. We get that our y-intercept is going to be at the point where x is equal to 0, y is equal to 6. And so graphing the information that we have, it's going to open up. We have 1/4 47/8. So 1/4 is going to be about right there, and it's just going to be shy of 6. We do have that we have a vertical axis of symmetry there, and we have no x-intercepts. We've already talked about how that makes sense with what we know. And then we have a y-intercept at the point 0, 6. Now we can use our symmetry to get a point on the other side. So the distance between this y-intercept here and our axis of symmetry is 1/4, because that's the difference in those x coordinates. Well, if we go 1/4 on the other side, we will get a mirror image of our point. This point right here is going to be at the point 1/2 6. And it gets us another point so we can get a better idea of our graph. All right, let's look at one more of these. So f of x equals -x squared plus 2x plus 1. Again, our leading coefficient there is a negative number, so this is going to open down. Our vertex is going to be at the point -b over 2a, f of -b over 2a. And so we get, let's see, our b value there is 2, and our a value is -1. -2 divided by -2 gives us an x coordinate on our vertex of 1. And then f of 1 is -1 squared plus 2 times 1 plus 1. Notice we are only squaring this x value here of 1, so we can think of that as inside parentheses. This negative is on the outside, so we're going to square first and then multiply by the negative following order of operations. So that'll give us a -1 plus 2 plus 1 gives us a y coordinate of 2. So our vertex is the point 1, 2. That is above the x-axis, and we're opening down, so we should get x-intercepts. We do have an axis of symmetry, again, at the line x equal 1, just whatever that x coordinate is that we got on our vertex. Again, on this one, if we multiply a times c, we get -1. There are no factors of -1 that add to a +2. So we are going to have to use either completing the square or the quadratic formula. So -2 plus or minus the square root of 2 squared minus 4 times -1 times 1 all over 2 times -1. We get -2 plus or minus underneath that square root. We're going to get 2 squared is 4, and then -4 times a -1 times a 1 is going to be +4, so that's going to give us a square root of 8 over -2. Don't be tempted to cancel out those -2's. Remember, we cannot reduce a fraction unless we can factor that common factor out, and we can't factor anything out of our square root just yet. We do need to simplify that. The square root of 8. 8 can be written as 4 times 2, where 4 is a perfect square, and the square root of 4 gives us 2, and then the square root of 2 cannot be simplified. Now we can divide out either a 2 or a -2 here. Since both of those are negative, we can divide out a -2. And when we divide out top and bottom by -2, we get 1 plus or minus the square root of 2 over 1. And that would be the coordinates of our x-intercept. Those are not values that most students are familiar with, so let's go ahead and look at a decimal approximation to be able to graph that. And those decimal approximations are 2.4 and -0.4, just to give us an idea on that graph. And then our last step is to find our y-intercept. And that's going to be a -0 squared plus 2 times 0 plus 1. So we get a y-intercept at 1. All right, putting all that together on our graph, our vertex is the point 1, 2. We have our axis of symmetry there. Let me scoot that over and get it actually on 1, 2. And then our axis of symmetry. And then our x-intercepts are approximately 2.4 and -0.4. And we have a y-intercept at 1. We can use a similar approach. We have a y-intercept at 1, and that's 1 unit to the left of our axis of symmetry. That means we are also going to have a point 1 unit to the right of our axis of symmetry. That other point there just gives us a better idea of our graph. And we are done. All right, I will see you guys next time.